construct confidence intervals here for proportions, and we'll also have a sample size formula. A couple of items here, symbol-wise, P is our population proportion, P hat, so I put a little hat on that P, is our sample proportion. Q is simply 1 minus P, so Q hat is 1 minus P hat. Then our formula here, we have P hat here, and we're going to use our sample proportions in here as well to construct our confidence intervals. Okay, so our confidence intervals, much like our mean, we're going to use our sample proportion to estimate our population proportion, so hence the variable P hat for our sample proportion. With all of our proportion problems, all of our proportions, we will always use a z-score, and we should know by now those z-scores come from table E. So those are the 1.65, the 1.96, the 2.58 that we've become accustomed to, 90%, 95%, and 99%. Those are the three most common ones. Obviously, we can find others by using our table, but those are the three common ones we will use. Bottom line is proportions. For all of our proportions, we use a z-score. Other than that, everything else here is pretty self-explanatory. One little side note, if we are working with a proportion but our sample proportion is not given to us, then we estimate, or not estimate it, but we assume it's 0.5, a 50-50 split. One other side note to make here, since we're working with proportions or percentages, those as decimals will go 3 decimal places, go 1 extra decimal place. So all of our proportions should be to at least 3 decimal places. You can see here also a formula for minimum sample size, inserting our variable or symbols here. P hat and Q hat are sample proportion, sample complement. We should be pretty well versed on our z-score. And E is our maximum error of estimate for our proportions. Our maximum error of estimate should be expressed as a decimal. So if we're given 3%, we write it as 0.03. Okay, so, and then also with our sample size, minimum sample size, just like we talked about in the first section, we always round up. So if I have 61.03, we round up to 62 for our minimum sample size. Okay, so again, those formulas themselves should be pretty self-explanatory. As far as the variables are concerned, we've worked with those variables before. We insert the symbol here to make this P hat and Q hat. Those are our sample values. We're using that to estimate the sample or the population proportion here. So we'll apply that right here in our first one. Find a 99% confidence interval. 99% is that z-score of 2.58 for a population proportion. So for our P, if our sample of 200, there's our N, and our sample proportion then is 42%. So P hat, let's just clean that up a little bit. P hat is 42%, which means that Q hat is 1 minus that, or 58%. So as we construct our confidence interval, our sample proportion is 0.42, our z-score is 2.58. Underneath our radical, we have our sample proportion, which is 0.42, times its complement, which is 0.58, and we divide that by our sample size, which is 200. Just notice that entire calculation is underneath the radical. And then 0.42 plus 2.58, and underneath that radical is 0.42 times 0.58 divided by 200. And if we plug that in, we'll get 0.330 to 0.510, so between 33 and 51%. Okay, so our confidence interval calculation looks very similar. Again, we can say we're 99% confident our sample, our population proportions going to fall between 33 and 51%. A couple more calculations here. Find the 90% confidence interval. So there's our z-score of 1.65 for a population proportion, P. If our sample of 98, there's our N, has a sample proportion or a P hat of 21%, which means that Q hat is 1 minus 0.21 or 0.79. So we go with our sample proportion of 0.21 minus our z-score, 1.65. Underneath our radical, we have 0.21 times 0.79 divided by our sample size of 98. And we construct our interval on the other side, 0.21 plus 1.65. And again, pointing out that all of this calculation right here, these three values, are all underneath the radical. So underneath the radical, I'll take the square root of 0.21 times 0.79 divided by 98, and that will give me my confidence interval, in this case 0.142 to 0.278. Constructing our confidence interval. One more time here. Sample of 500 nursing applications included 60 from men. Find the 90% interval, 1.65, of the true proportion of men, or our P, who applied to the nursing program. So notice in this case it says 60 of the 500 were from men. So in this case we'll come over here to the side and calculate P hat by taking 60 and divide it by 500, and that will get us a sample proportion of 12%. So P hat is 12%. Our confidence interval, our z-score is 1.65. Then we have 0.12. The complement of 0.12 is 0.88. We divide that by our sample size, which is 500. We're constructing our interval for the proportion. So we have 1.65 and 0.12, 0.88, and 500. And our interval runs from 0.096 to 0.144. Okay, so I'm going to assume, backtrack here, plug it in here, but I'm going to assume we all knew that Q hat was 1 minus 0.12, or that's where I got the 0.88 from. There's our Q hat, P hat, and Q hat, 0.12 and 0.88. Find the minimum sample size. So notice how the directions are different. Find the minimum sample size, or N. So I'm going to copy or put that formula back down for us again, just so we can say we've seen it a second time. P hat times Q hat times our z-score over our maximum error of estimate, and we're squaring that value. So in this case, our 90% is our 1.65 for a population proportion, so that tells us to use this formula, not the one we had back for our mean, and we want it to be accurate within 2% as our E. But if you notice, there's no mention of a sample proportion here, so that goes back. I'm just going to backtrack and underline it for us right here. When P is unknown, or P hat is unknown, use 0.5. So I'm going to go back to here. My minimum sample size is P hat, which would be 0.5. Q hat then would also be 0.5. Our z-score is 1.65. Our maximum error of estimate is 2%, and we would square that number. If we do that calculation, we get 1701.5625. And as we mentioned back in the first section, make sure that we always round up. So our minimum sample size is 1702. So hopefully we can avoid that mistake. Make sure for your minimum sample size you always round that up to the next whole number. We'll see that a second time, or a second and third time right here. Find the minimum sample size to find the 90% confidence interval for a population proportion. Proportion tells us to use that formula, P hat, Q hat, our z-score over max error of estimate squared, if we want it to be accurate within 4%. So our P hat, once again, there's no mention of proportion, so it's 0.5, which means Q hat is 0.5, 1.65, in this case 0.04. We square that, and we're going to get 425.390625. Always round up, so our minimum sample size is 426. Going to go through that process one more time with our minimum sample size. Researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. Here's our proportion. Previous study shows that 40%, there's our P hat this time. Those interviewed had a home computer. The researcher wished the interval be 6% wide, so this is a little bit different. Find the minimum sample size, or N. So one more time, I'm going to write the formula up here, P hat, Q hat, z-score, maximum error of estimate squared. So in this case, our P hat is actually spelled out for us this time. It's 0.4, which means our Q hat is 0.6. Our z-score is 1.96 for the 95% up here. Now we want the interval to be 6% wide, which means I can go above and below my mean by 3%. Half of the 6%, our interval is 6% wide, so I can go up 3% or I can go down 3%. That means my interval would be 3% wide or 6% wide. So in this case, our maximum error of estimate is 3%, not the 6% that you see listed here. So I hope that makes sense. That gets me 2304.96 when I plug that into the calculator, or again, we always round up 2305 as our minimum sample size. Now I'm going to backtrack here one time, noting the phrasing here. Our interval is 6% wide, as opposed to our previous one where it says we want to be accurate to 4%. So in this case, if my mean were here, I could go up 4% or I could go down 4%. Down here, if I want my interval to be 3% or 6% wide, that means I can go up 3% or down 3% to construct my interval. And you can see my interval will be 6% wide, or my maximum error of estimate, E, would be 3%. And that covers our proportions.